This is the first video on expansion of liquids. So let us start. How expansion of the liquids is different from that of the solids. If I have to say that, how does solid is different from the liquid, we shall understand. So this what I have drawn is a solid. What I have drawn in the next is a liquid. How solid looks like? The molecular force of attraction between the molecules is very strong in a solid. Is very strong. So the molecules are very close to each other and they occupies minimum possible volume. That's the case of a solid. But in the case of a liquid, the molecular force of attraction is not that strong of the solids, like that of the solids. And it occupies obviously more volume than that of the solids. Next, solid can have a fixed shape. Solid do have a fixed shape, whereas liquids can't have their own shape, and moreover they need a container to hold them together. Solids don't need a container, but liquids need a container, and they get the shape of that container itself. That's a serious difference when compared with the solids and the liquids. As force of attraction is more in the case of solids, expansion is less. As force of expansion is less in the case of liquids, expansion of the liquid is more than that of the solids. That's how we can compare solids and the liquids in the basic aspects, like molecules are quite far to each other, force of attraction is more in solids, vice versa, occupies less volume, solids more volume, liquids. Solids have a fixed shape, liquids won't. Solids don't need a container, liquids need a container. Solids comparatively expands less than that of the liquids. Our liquids expands more than that of the solids. After understanding that basics, the next aspect that what we need to understand is, as I told you, solids in the early we learned earlier, like has expansion along the length, we call it like a linear expansion. Along the area in 2 dimension, we call it like aerial expansion. And they also have an expansion along the volume called volume expansion. To measure that, we have defined the coefficient of linear expansion, coefficient of aerial expansion, and coefficient of volume expansion. Thus, the solid has three different kinds of expansion coefficients. But liquids, come to liquids and check what happens. Liquids don't have any length. Why liquids don't have any length is they are not having their own shape, rather they have a shape of the container itself. Whenever container changes, their length appears like changes. Liquids also don't have a particular shape, and hence their liquids don't have any area. So no linear expansion coefficient, no aerial expansion coefficient for liquids. We need not define linear expansion coefficient and aerial expansion coefficient for liquids. Liquids have a particular volume. Liquids have a particular volume, and hence we have only volume expansion, and we define only gamma. So unlike solids who have linear, aerial, and volume expansion coefficients 3, liquids are not going to have linear and aerial expansion. Rather, they are going to have only volume expansion, right? So I have already explained this point. Why liquids expands more than solids, we have already explained. Now we want to talk, how do we measure the expansion of the liquids, right? That's the next point that we would like to touch. As I told you already, to understand the expansion of the liquids, first we need to understand that a liquid cannot be hold itself in our hand If you want to heat up the water, you will take water in a vessel and then you will put it on the stove. We need a vessel to hold that liquid, right? So, how do we do that? Let us say this is a vessel. In this vessel, we take liquid and then we heat it up, right? So, liquids need a container. So, we have kept it on a Bunsen burner, say for example. Let the liquid level is up to A. We have taken up to A. And now you have heated it up. What happens when you heat it up is, the first thing that happens is, this container will absorb the heat that is given by you. So that container expands a little. That's not visible for you like I am drawing, but that liquid container, the solid expands. As the solid expands, the liquid level falls down from A to B. It has fallen down from A to B. So why the liquid level has fallen down from A to B? A to B fall of liquid level is because of volume expansion of the container. Volume expansion of the container. Now the liquid level though has fallen to the level B, it's not visible for you. You won't be able to see it. You see liquid level at A itself. For you, liquid level appear like at A itself, though it has fallen to level B. Now you assume that you are supplying the heat further. You have heated it further. Now the liquid level rises. Liquid level rises. Liquid level rises from B. But for you, it appears like rising from A, because falling from A to B is not visible for you. So it will rise to a new position, say to a level C. It has actually raised. It is actually raised. Actually level raised from B to C. But it appears as if like raised from A to C. So it's rising actually from B to C. That kind of expansion is called real expansion of liquid. But it appears for you for a normal naked eye like it is rising from A to C. That's called apparent expansion of the liquid. So I want you to understand that liquids don't have any linear expansion. Liquids don't have any aerial expansion. Liquids have only volume expansion. But that volume expansion is of two types. Volume expansion of liquid is not one type, it is two type. How it appears for you, that's called apparent expansion. How it is really happening, that is called as real expansion. So in our diagram, if you notice carefully, as I told you earlier, AC is how it appears like apparent for you, represent apparent expansion of a liquid. But if you see, actually it is rising from B to C. So you can say BC is a real expansion of the liquid. And as I told you earlier, AB is liquid has level has fallen from A to B because volume expansion of solid container. Now it's very clear from the diagram that the total BC is equal to AC plus AB. So in this kind of a case, you can say real expansion is sum of apparent expansion plus volume expansion of container. Well, then there is one more. How do you measure these expansions? This is the next thing that we would like to talk. This one. We will say there are expansion coefficients like apparent expansion coefficient and real expansion coefficient. We are postponing it to the next part of the video. We'll do there. But we'll say on what factors that the real and apparent expansion depends on. It's very clear that real expansion depends on, if you say real expansion, that real expansion depends on, that real depends on nature of that liquid, nothing else. Depends on nature of the liquids, whereas the apparent expansion depends not only on the nature of the liquid but also depends on nature of the container taken, because it's because of the container which the liquid level falls down from A to B. So real expansion depends on nature of the liquid. It's the same for a given liquid under all circumstances, but apparent expansion varies for a given liquid depending on what container is there, right? I'll stop there for that in this part. In the next video, I will identify what's the relation between real expansion coefficient and apparent expansion coefficient. Thank you for watching.